Hello, today's creature feature is on sponges, and to get everybody excited about this magnificent animal, I found someone very interesting on the internet to introduce you.
When people think of a sponge, they usually imagine something like this: a cleaning sponge for washing the dishes, or for washing the car. Cleaning sponges are synthetic these days, but they used to come from the ocean.
Sponges belong to the phylum Porifera, and are a commonly known marine organism to most. It is estimated that up to 10,000 species of sponge exist throughout the world's oceans, with a handful of freshwater species as well. Their existence definitively dates back 580 million years, with some contested fossils dating their existence back over 800 million years. While they have been popularized by the internet meme sponges that look like the Cookie Monster, and, of course, Nickelodeon's children's show, SpongeBob SquarePants, their marine existence is equally, if not more so, important. Sponges are multicellular filter feeders with a porous form that allows water to circulate through their bodies. The passing of water through their bodies brings with it all the biotic requirements the sponge requires: food, oxygen, and a medium to remove their waste. Sponges most commonly feed on floating organic particles and plankton, but some rarer species have been known to house photosynthesizing microorganisms as endosymbionts, and these couplings often produce more food and oxygen than they consume. A few species of sponge that live in food-poor environments have even become carnivores that prey mainly on small crustaceans, but this development is extremely rare. Sponges are common marine animals found all over the ocean, from the polar seas of the Arctic Ocean to the tropical Great Barrier Reef off the coast of Australia. Sponges are more bountiful but less diverse in temperate waters than in tropical waters. It is hypothesized that tropical waters house more of the sponge's natural enemies, causing their populations to be limited. Additionally, the oceanic zones that the sponge populates equally diverse, as they are found in tidal zones and to depths of over 5 miles and everything in between. Physiologically, the family is not as complex as many multicellular animals, as they lack both a nervous and digestive system, or even true tissues or organs. All sponges are sessile, and the shape of their body depends greatly on their environment, as they grow to maximize efficiency of water flow through their central cavity. Their bodies generally consist of 2 thin layers of tissue separated by an abiotic jelly layer, through which the water flows. Sponges generally prefer calm, quiet, and clear waters, as sediments stirred up by waves or currents would block their pores, making it difficult for them to feed and breathe. Additionally, strong physical stress may dislodge their bodies from their rooted plane. Most species of sponge use sexual reproduction, releasing sperm cells into the water to fertilize ova that are either released or self-contained by the mother. Sponges may also replicate by regeneration if the fragment contains the necessary assemblage of cells. A few species even reproduce by budding, but this is significantly less common. All known living species of sponge can remold their bodies, as most of their cells can move within their bodies, and a few can even change from one cell type to another. Sponges' ecological role is also important, as they are the prey of turtles, certain fish, and sea stars, but are unattractive prey to most marine life because of their poor taste and chemical defenses. Additionally, sponges play major roles in nutrient recycling through their interaction with the water and coral reefs. Sponges possess the ability to indirectly recycle nitrogen in ecosystems, as their bodies often collect bacterial deposits which fix nitrogen. It is now believed that sponges prevent ammonia buildup in reefs, acting as a keystone species in many reef communities. Sponges have been identified as a possible indicator species, as they interact directly with the surrounding water. As global oceanic temperatures rise, in addition to the acidification of the oceans, sponges are being studied for their response to these changes. They face larger threats from global climate change, ocean acidification, torus removal, and turbidity in highly trafficked areas. Finally, sponges are often commercially used as cleaning products because of their ability to absorb and withhold water.